So, next steps. This is where a really important equation that we came up with the other day comes into play. Because now we know what the FU is, okay? We know the FU experienced by this system is 18 newtons. We know the mass of the system in total is 9 kilograms. Who's got a calculator? Can you figure out the acceleration experienced by the system?
I don't think they come every
So it's FU equals MA. So this is something that can prove problematic. Oh, look at that, what a pitch play. We're gonna make mailboxes for Valentine's next week, so let's just hang on to it, George. Yeah. All right. So, hey, little red flag, common mistake. This is calling for the mass. This is calling for the unbalanced force. Those things have different units. If I'm talking about the unbalanced force, that's going to have the units newtons. If I'm talking about the mass, that's going to have the units kilograms. So 18 newtons is going to go over not 90 newtons. That would just give me an answer without units. Newtons would cancel out newtons. You wouldn't do that. This is West High. Okay, not some lesser high school in the district. So I'm not going to divide by, we got options now. Okay. Oh, shit. All right. It's not in the district, bro. Don't slam on my clippers. All right. So I said lesser school in the district, bro. All right. 18 newtons over 9 kilograms. So other things to keep in mind, dimensionally, a newton is equivalent to a kilogram meter per second squared. Ooh. Whoa. Whoa. Don't do that, Mr. Harding. Okay. So in other words, what I'm doing here is taking 18 kilogram meters per second squared, dividing it by, Microsoft OneNote, why have you stopped working? Why have you started working again? So this is 18 kilogram meters per second squared divided by 9 kilograms. Kilograms cancel out. 18 over 9. Who's got a calculator? Aya? 2 units.
Yeah.
Meters per second squared. And that should make sense as a unit for an acceleration. This is telling us about the motion of the system. You all right? Come on. This is telling us about the motion of the system. It's 2 meters per second squared. That means that the acceleration of the 2 kilogram block is going to be how much? Peaches says 2 meters per second squared. Do you agree with her? What is the acceleration of the 3 kilogram block going to be? 2 meters per second squared. Okay, so this is the benefit of the system analysis. We figure out the acceleration of the system. Now we know the acceleration of each individual object. Now you can come back to your 2 kilogram object, and you know its acceleration has to equal 2 meters per second squared. You know its mass is 2 kilograms. How big does the FU on the 2 need to be? You following me here? This box is 2 kilograms of mass. It's got an acceleration of 2 meters per second squared.
4.
Okay, check out the brains on Castor. So this is experiencing a 4 Newton FU. FU2 equals 4 newtons.
How'd you get 18 newtons equals 18 kilograms meters per second squared?
From our lab, this was one of the No, good question, because this comes up a lot. From our lab, we established that those things are equivalent units. All right. The 3 kilogram box. What's its acceleration? What's its acceleration? 2 meters per second squared. It's part of the system. What is the FU experienced by the 3? If it's 3 kilograms of mass and it's got a 2 meter per second squared acceleration.
Or 6 newtons.
It's rubbing off on you, Riley.
Exactly.
All right. So finally here, I've got a 4 kilogram box.
2 meters per second squared is the acceleration, and then 8 meters.
Gigi says acceleration 2 meters per second squared. And then FU equals 8 newtons. How'd you get that, Gigi?
I just
2 times 4 is 8.
I knew how to do 2 times 4, but I don't know why I did 2 times 4.
Because
I just knew that.
Goes over.
I don't think I said that.
Fair enough. Okay, let's make sure we're conscious of what we're doing. When I'm asking you to find the FU for an object, you're going to take the mass times the acceleration if it's known. We know the acceleration because we know the acceleration of the system. Each thing in this system has an acceleration of 2 meters per second squared. And then if I know the mass of the object, I know how much FU it's got to have. Okay? These all have the same acceleration. They do not all experience the same FU. That's why the problem was really complicated when we were trying to go through and solve it yesterday. You guys were all over the board with your different FU values. But here's the thing. If I look at, I'm going to go ahead and do the easy one because I'm lazy like that. I went to Clinton where excellence is a word we can't spell. So if I look at the 4 kilogram object in my system schema, there are 3 lines that contact it. It's experiencing 3 interactions. How many forces should there be on my free body diagram for it? 3. That's how that works. Okay. So if you look at the system schema, these 3 interactions the 4 kilogram is experiencing, I already know the values of 2 of them. I know there's 40 newtons of gravity. I know there's 40 newtons of smoosh poosh from the floor. The only thing I don't know the value of is the smoosh poosh. So watch how this works. I'm going to draw my arrows on here. I've got 40 newtons, FG. This would be 4, Earth. And then I'm going to have 40 newtons, FSP, 4, what's pushing on the 4? That'd be the floor, right? This upward smoosh poosh is from the floor. Those arrows balance. I've identified 2 of these. They balance. 40 newtons up, 40 newtons down. We've also determined how big does the FU need to be. Okay? I got to get an 8 Newton FU. What's the source of that force? Of course. Run that by your neighbor. Okay? And then over in Le Pair Deck, what I'd like you to do, don't worry about drawing an entire free body diagram, but I'm looking for you to draw my missing arrow here. So in the Pair Deck, draw the missing arrow for this diagram. How much is it? Which way is it pointing? What's the feeler dealer? Keep in mind you got text tools. You don't need to write letters with your finger on the touchpad. You can't draw? That would make it challenging to draw, clearly. Now you may try to draw that arrow. Thank you. Because my friends walk or ride their bikes to class horse hour, so we have hot coffee with them. Do you walk to school? No, I'll stop at the coffee shop and buy your company. I thought it was inequitable that all my other friends that were shuffling here outside don't have coffee. I made it up 10. Well, it's kind of nice. Because I bought like the cheapest coffee. We'll just give you an upgrade, dude. We're taking great value Columbia.
Oh my gosh.
Still nice, yeah.
Kind of. Yes.
You just do hot water and have a big lunch.
I have hot chocolate over here. And so,
I think they
unfortunately, language barriers, somebody tried to make the hot chocolate by putting it in the basket like a filter. Just let it in. I'm like, why is the water so low?
Organic dried mango bites.
I do have a pitcher down here that my friend Shintaro is going to run.
Did
That's
anyone
for
make
hot chocolate. So if you ever want hot chocolate, you're going to have to provide your own portion.
You won't get to.
How do I
For the 4 kilogram object, I'm looking for your missing arrow. Hey, I'm looking from here. I can't see who it is. You don't need to draw the whole free body diagram. I just need from you the missing arrow. How much is it? What is the feeler dealer? Which direction is it pointing? Really want you to be thinking about the feeler dealer on this. This is going to be really important. We're coming back around to probably one of the biggest, most difficult understandings in all of introductory physics. Such a difficult thing that all of the physics teachers in the district are getting together on Thursday to talk about how we teach it. So I'm going to play for them this screencast where I slagged off the other schools in the district and then swore.
They're good. I feel like a frozen mango.
Question, lady? What?
Wait,
How many grades are in you?
how do you? Does anyone does ever just like line up and the first one to make it? I'm doing it. I'm doing it.
Going to be able to?
Yeah.
Where'd that go?
I'll just leave the last one.
Yeah.
Yeah.
What if they're whole fast?
I didn't want Chick-fil-A for free for 1 year. It's
How many grades?
any Chick-fil-A I want. Yeah. How did they get that?
They're sponsoring us. Just so before you give it, that's.
You guys have a big student section last time? Did you go?
Yeah, of course I went there. It was me,
Our student section is busted.
Ashley, Maya, Grace, and
Friday will be huge.
So now you're drawing a free body diagram for the 4 kilogram. These arrows are balanced, but this 4 kilograms has to experience an acceleration of 2 meters per second squared. We've already done the math. Gigi told you the unbalanced force has to be 8 newtons. I'm asking you, which way is it pointing? What is the label on it? Oh, this is us. We're making progress, gang. Talk to your neighbor. Chances are your neighbor's doing it right because everybody looks good in the pear deck.
I'm gonna guess it's this way.
What up?
Did I guess it right?
I don't know. Talk to your neighbors about it. See if they can make sense of
It's
it.
one way or another. I have a 50% chance of getting it.
Which direction is this thing accelerating in?
I feel like low key like a
So the FU would go down.
Look at the note up there. It says FU and acceleration always point the same way.
Also, so I did that wrong.
wait, I thought the FU was going this way, so I put that in.
But you're doing it the opposite way.
All right. Conversation I just had up here, which might be pertinent to you as well. This is one. Rare are the always things in science, but at least in physics, FU and acceleration always point the same way. Think about the direction this thing is being pushed. Which direction is it accelerating in? The direction of acceleration for this 4 kilogram, is it to the left or to the right? To the
Left.
Left.
I don't.
It's being pushed that way. So if this was the bowling ball, we're hitting it that way.
So
It's accelerating to the right. Just because I'm asking you questions doesn't mean you're wrong, dude. Don't gauge your rightness or wrongness on whether I ask
She
you a
doesn't like
question.
to be wrong.
Isn't the FU supposed to go that way?
Okay, so here's the issue. I'm saying the acceleration is going to the right. That would indicate the FU needs to go to the right. That's how that works. So if we look at everybody and their mother over in the pear deck, they're showing that this arrow needs to point to the right. What would be putting a force to the right on this thing? Oh, come on, battery. Why are you going to do this now?
Person pushing.
Who pushing?
Yeah.
What's pushing on it?
Person pushing.
Is the person pushing on box 4?
No, they're pushing on box 2.
Yeah, what's pushing on box 4? Let's dive in and take a closer look at what our friends are saying here in the pair deck. Shh, shh, shh. Ooh, ooh, ooh. Look, 4, 3. Deleted response. Ah, no labels. 4, 3.
But wouldn't that, if you ever go
Ah! Okay, so I would beef with this. The person is not pushing on block 4. And we're no longer talking about blocks. We're talking about one block. We're talking about the 4 kilogram block. 4 kilogram feels it. 3 kilogram deals it. Okay? And I forgot to bring balloons again. Does anybody have a balloon with them?
Yeah, I got one right here. Right here.
Okay? So over here,
We should put some girls game to go 7.
Why would we ever do that?
Why? Because
who would playing?
City?
On Friday?
Yeah.
Oh my gosh. Stay away from this place.
It's like at the end of the girls game, there's
All right.
a lot of people because the guy thinks that.
So if this is my diagram, and I then draw a force addition diagram for it, I'm going to go 40 newtons up. This is the smoosh poosh. I'm going to go 8 newtons over. This is the other smoosh poosh. I'm going to go 40 newtons down. This is the gravity. Okay. These don't balance. And this, again, I want to share with you because this is something else we were struggling with on the quizzes, the direction of the FU. The FU is going to begin at the beginning. Here's the beginning. Beginning. And then this is the end of my diagram. The FU is going to begin at the beginning and end at the ending. So the FU in this case is pointing the same direction as this 8 Newton force. How big is this FU? It's 8 newtons. That's how big that gap would be in this rectangle. So thank you to the two of you still paying attention up here. Okay? This is how you draw the direction of the FU. And again, I'm looking for agreement between the direction of acceleration and the direction of the FU. They've got to both. That makes it harder to see. Don't do that. All right. There we go. Wait.
How'd you get 8?
How'd I get 8? Great. Gigi, how'd I get 8?
Without balance force, right?
Chew your food. Chew your charcuterie.
It's actually pretzel balls today.
Lo siento.
You want me to repeat?
I'm stalling so you can chew. Riley, help him out here.
I can chew and.
No, you cannot. I'm going to end up with salt and gluten on me. All right. Somebody help out Grack. How do we get 8?
FU equals M times A.
I was
2
right.
times 4 is 8.
FU equals M times A. The M is 4 kilograms because we're just talking about the 4 kilogram box. We know everything's got an acceleration of 2 meters per second squared from the system part of it. Everything has to have that acceleration of 2 meters per second squared. So 4 kilograms, 2 meters per second squared, 8 newtons of FU. And to get an 8 Newton FU, that's how I know things. That's how I
I don't
know
want
that
to get
the
dirty. So.
smoosh push from the 3 that the 4 is feeling must be 8 newtons. Now, that was the easy part, right? But watch this. Now I can go into my system schema, and if I know the 4 experiences an 8 Newton smoosh push from the 3, I can label this. Hey, gang, this is the real utility of the system schema.
You're welcome.
I know that this interaction is 8 newtons. So now if you look at the 3 kilogram, how many interactions is it experiencing? 1, 2, 3, 4. 3 kilograms should have 4 arrows on its free body diagram. How many of those arrows do we know the value of right now? 3 of them. We only have one unknown, but you know that you need to end up with an FU of 6. Get after it, okay? On your whiteboards there, draw your free body diagram for the 3 kilogram block. On the whiteboard.
Yeah.
That one's cool. Okay, right. Let's get it going.
I'm right here. Pretty cool.
Oh, cripes.
At 6, isn't it? Go ahead. What do I do now?
Make it.
Make what? Should we erase these?
Yeah, probably, but.
So, coffee going in a coffee mug?
Yeah, this coffee got cold, so I'm adding some hot coffee to it.
Is that a Yeti mug?
It's little physics. Yeah, it's a Yeti mug. It shouldn't be getting cold, but it is.
We're a big Yeti fan. We got a big
Are you?
Yeti cooler, Yeti hat, Yeti mugs.
So the Yeti mugs are pretty dope.
We are seeing.
This is from my rich sister-in-law. She always buys me something real fancy for my birthday every year and leaves a price tag on it because she's classy like that. She wants me to know my value to her.
A low key like.
Now these are the Walmart Bubba mugs. If ever you were in a financial pinch, say like you found yourself in the unfortunate condition of being a public school teacher, these are affordable to you. Keeps it pretty warm.
$5 mugs.
More than that, but not Yeti prices. Keeps it hot all day.
Then you just need some good coffee, and then you'll.
Oh, I have good coffee. This is the justcoffee.coop WTF blend. Periodically, they do a 30% off sale. So I bought 2 5-pound bags. So I'm working my way through bag 1 right now.
I do not like that coffee.
Oh, yeah, no, that coffee's booty. I bought some fancier stuff on the weekend, but I didn't realize it was whole bean. I don't have my grinder here, so I'm going to grind it at home and then bring it
We have
back.
an espresso, so.
Do you have a Ninja espresso maker? What's your...
Probably. But I get the high end, like little pods and stuff.
Yeah, little espresso. I need bulk. Like I like the kick from espresso, but I need the bulk.
Yeah. We have a normal one like that.
Yeah, you just throw like the shot of the
Yeah, I
espresso
think
into the regular coffee.
We get like the coffee from Starbucks and just like put that back.
So this is 14 years.
Oh, and if you twist up my slinky, I'm gonna twist up your knee ligaments. 2-footed all day. Yep. All right. So again, what I'm asking for you to do on your whiteboard is draw the 3 kilogram arrow. Stumpy and I decided it should have 4 arrows on it because there are 4 lines connected to the system schema. Stumpy. Because it's hard to say Stumpy. Stumpy. It's tough to say. What? Don't say that. You coach Stump as well?
You can figure out what
Are you guys related? Are you Christian family from Norway, Iowa? No. Yeah. I've worked with the man for 20 years. That's for like 17.
Oh, okay.
Then would this one be sent to us?
There, I think you got it.
Is this
I get the basic one, but what's the air on the left one? I probably
So now do I have to draw that in?
What up?
Do I need to draw that?
So here's what I'm going to say in the pair deck. Re-ask the same question. All right, in the pair deck, here's what I want. Not the whole free body diagram. I want the force that would be called 3, 4. I want the force that the 3 feels from the 4. Which direction is it? How much is it?
8 Newtons.
This sucks because I did totally bag on the other high schools, and I am going to want this lesson as an example of like how we go about this. Oops. I just called them the lesser high schools in the district.
Yeah, that's why I said you're on recording.
And I wouldn't say that, like, if they didn't have the stupid tagline, the school that leads. Leads what? Leads in being behind in the fourth quarter in basketball. Like, is that what it is?
Everything they do?
Oh, wait, they are good in basketball, aren't they?
No.
They are girls.
Girls, yeah. Hashtag the Jones family. Is there still a Jones there?
Yeah,
There's like
there's
3 more.
There's 2 more coming up.
See, at my level, I got to deal with like the Woodridge family from up at CPU. They're all like 6'2". I think there's still one playing. Did you guys ever play against them in like
CPU, I
other
think
ball?
the state. So regional championship was held at West last year, and CPU played in it with girls
Track or basketball?
basketball, and it was like
There were so many.
the crowd for those schools are
They
insane.
can't. Yeah,
It's like
and they're
then we had
gigantic.
our game after.
I've
There was
never-
like 10 people.
Like I'm like 230, 6'2". Like usually when I go through the handshake line, I'm bigger than all the players on the other team. But like they have girls that are bigger than me, and that makes me scared.
Aubrey.
All right. What I'm asking you to do in the pair deck right now is not draw the whole free body diagram for the 3 kilogram block. I'm only asking for the force that you think would be labeled 3,4, the force that the 3 feels from the 4. Give you a few more seconds here. What direction, what amount? Don't worry too much about the amount, but more so, what's the direction of the 3?
Did I get the first one?
All right. So I'm gonna lock it down. And this is what I see in here right now. Is there a consensus? Are we all in agreement here?
No, we're not.
No.
We are not.
Oh, we're close.
So I need you to talk to your neighbor about why you're drawing that force, the direction you're drawing it.
Because the 4 kilogram block where it's pushing back, it says it's in front of the 3, it's pushing back.
I probably understand it. I didn't pay attention, but
Right?
what is this arrow? Like what is he asking for? What is he asking for?
He's asking for the arrow that the 3 feels from the 4.
Oh, that's easy.
See?
I just don't pay attention.
What's 4 times 2? I don't understand.
No. Fuck you.
I don't understand.
No, I knew how to get 8, but and then I knew 4 times 2 is 8, but I said no.
Oh, did you? Did you?
I would say something again.
You always say that.
Because what I want to say is rude. And I don't-
But, no, I'm just not going to. Okay. I'm just going to keep them.
yeah, that's unlike Audrey. She expresses.
Oh, you're like Audrey?
No, unlike Audrey. She expresses all her.
Well, maybe you make her want to do your angry things.
I do. Trust me. She gets flustered during AFC.
All right, this is what it looks like now in the pair deck. This is everybody's answers overlaid.
Did 100 slingshot?
No, like 10 of us.
So no one got like the first 10. But
Just as somebody to the right is going away, somebody's joining them to the right. Okay? So, hey, the wind is blowing to the left, my friend. Why? Okay, so I don't need to lock that. I need to freeze that. My question to you is this. Why are you drawing that force that way? So let's do this, not make a multiple choice, Mr. Harding. There we go. Why are you drawing 3,4 the direction you're drawing it? Whoa.
What sounds like
I'm not scheduled. I'm trying to take personal planners and like no open net stuff. So the next year I'm screwed up. So I have to open it.
classes next year.
What do you mean? I'm gonna have 2 open things. Bummer. First and second.
Classes.
I think, well, but AP math, AP Spanish, AP, sorry,
Which math are you taking?
AB. I think
Hey, I've only got like 8 people in here. I'd like to hear from some more of you. I want to know, what is your rationale for drawing this force the way you're drawing it?
Isn't it like substance?
what's the difference?
You get credit.
You get credit perfectly.
Yeah.
Are you gonna go with her?
No.
I think if you
Get choices.
I'm taking,
But then I'm also taking 2
All right, so here's what our friends are saying on the internet. Because the 4 kilogram box is pushing back on the 3 kilogram box. Because the 4 is in front of the 3, and in a way, it holds it back, so it would be a left arrow. So, you can kind of think about it that way. Like, what is life like for this 3 kilogram box? Is it made easier or made harder because this 4 kilogram is out in front of it? Yeah? It's the direction that the 4 is pushing on 3. 3 kilogram box is to the left of the 4 kilogram box. Woo! This is another important thought. This type of force is a smoosh poosh. Earlier in the year, we came up with that rule set. Smoosh pooshes point how relative to the dealer? Opposite. So if the 4 is over here, the smoosh poosh, the 3 fields from the 4 has got to push away from the 4. That's a really important understanding as well. Okay? That's great. So you guys are all having some really, really good thoughts here. So I'm going to go ahead. I'm moved to draw this arrow like this. This is smoosh poosh, 3, 4. It is 8 newtons. Ooh! 1, 2, 3. 1, 2, 3. 8 newtons. 8 newtons. Same size, different directions. Why? Because
Because it's second day opposite.
forces come in pairs. This is a force pair. This is one interaction. 3 and 4 are pushing on each other. Same amount, different directions. Ooh, big brain right there. Okay? All right, so 8 newtons that way. 30 newtons down. This is FG 3, 4. 30 newtons up. F smoosh poosh 3, floor. All right, gang. New question. What's missing? Okay. Go ahead and draw me the missing arrow. Feeler, dealer, amount, that sort of thing. Join the party on the pair deck.
I'm going to get first and
So what is missing from the 3 kilogram right now? Hopefully you're not on multiple choice. I'm querying you for amount and direction of force missing. What's the missing arrow?
You already finished that?
Yo, Gigi, got to take a leak?
No.
Name the movie.
How many cups, if you had to guess, how many cups of coffee did you drink today?
Enough. Pot and a half.
A whole pot by yourself.
Easily.
2 cups of coffee getting me going.
I habituate it. Yeah, I need something legal, but more intense, and that doesn't exist. So here we go. Just a high volume of coffee. Sometimes I just take spoonfuls of coffee and just put it in like.
Please not from that.
Oh yeah, we're recording all this. Don't worry about it. This will be good. You can come back years from now. Hey, remember that one weird day in class? Oh, that one weird day in class?
Does this go on your class notes?
Yep.
So whoever's looking at this can hear it.
Yeah, exactly.
This
All of our
on YouTube
weird
too?
conversations. It's on YouTube. Yeah.
A couple F-bombs might have dropped. That's not me.
No, it was Aya, clearly. No.
So,
CC, Brigham Parlay. So you know that this is the thing. This is gotta be this.
Three,
This is gotta give you all you.
if I can get,
Remember here, this is FU is 8. FU is 6. FU is 6. So what does the other arrow have to be? So the FU is 6. Okay? So the important thought that my Spanish-speaking friend El Graca just shared with me over there. This FU's got to be 6 newtons. That's your check. Okay, if you add your arrows together, the arrow you just drew, do you get a 6 Newton FU? Is it pointing in the correct direction? I'm not sure that's true based on everything I'm seeing in here. Okay? Keep in mind, we already said the acceleration is that way, and they all have to have the same acceleration. So I need an acceleration that's that way. Keep in mind, we said that FU and acceleration point the same way. How do I get the right amount of FU pointing in the right direction? Let's see what our friends are saying in the Pear Deck right now. Oh boy, those are small. I got 14 newtons in the forward direction, 3,2. Run that by your neighbor. 14 newtons, 3,2. 2 newtons, 3,2. 14 newtons, 3,2. 8 newtons. 6 newtons. 14 newtons. 14 newtons. 2 newtons. So those are kind of the options. That's not how scrolling works, Mr. Harding. You can't see that. All right. So I'd really like to display these all three at once, but I can't. So here's the 3 different options I'm seeing in the Pear Deck. 8 newtons. Hey, friends, let's get there. 8 newtons to the right. 2 newtons to the right. 14 newtons to the right. One of these I think we can eliminate because it doesn't give us an FU of 6. Which one is that? 8. What is 8 going to do to this diagram? Yeah. If I put an 8 Newton arrow here, these are balanced. Are they balanced?
No.
No, we said this thing accelerates. It's got an FU of 6. If I put a 2 here, am I going to have an FU of 6?
No. Or yeah, but
if I put a 14 here, am I going to get an FU of 6?
yeah.
So it's one of those is likely. Hash it out with your neighbor there. What makes more sense for this 3 kilogram box? 2 newtons or 14 newtons here. Both of them give an FU of 6.
those 2 newtons and What'd you do if I just
I would tell it.
This makes no type of sense.
Are you Audrey Jones? You're dating Audrey Jones?
No.
Oh.
Not
Yeah, he's dating Aubrey Jones.
Aubrey Jones.
no.
Is that the one that's at Iowa State, or is that the other one?
That's
Still
the one
there?
I would.
What's the one? Oh,
Ashley's
Ashley.
at, Kelsey's at,
Cripes. No pressure in that family. Again, I'm watching the Pear Deck, looking for you to make some changes here potentially. Joseph, your Chromebook and charger are in the back on my desk. One of them is yours. One of them is Jacob Steffens. All right. So, again, we got good agreement on direction, but I've got 3 different values of arrows, and weirdly, you're all drawing them like certain lengths. There's a group of 2 newtons. There's a group of 8 newtons. There's a group of 14 newtons. We got to have a 6 Newton FU. Which way does it need to point? And so I'm going to give you this rationale. We've already said this is accelerating to the right. This is experiencing an FU to the right. That means this is accelerating to the right. It's got to experience an FU to the right. The only way I'm going to make that happen is if I make this force 14 newtons. 1, 2, 3, 4. This is FSP 3, comma who? 3, comma 2. The 2 is pushing that hard that way. If I add these together, I'm going to have 30 up, smoosh poosh. I'm going to have 14 to the right, smoosh poosh. I'm going to have 30 down, gravity. I'm going to have 8 to the left, smoosh poosh. That's going to leave a gap right here. That gap, well, look, 14 to the right, 8 to the left. That gap is going to be a 6 Newton FU. I've got to have 6 newtons of FU. My acceleration has to be to the right. That means my FU has to be to the right. That's how I know that this has to be 14. Because I need to get a 6 Newton FU pointing to the right. Okay? The last one's on you. Hit that 2 kilogram FBD off the tee there. What's that got to look like? That's your exit with your friends. At 13.
18 line that way.
That's true.
Wait. Yeah. And then
Go to C over by
Alice.
Alice. Over there, and I'll get with you in a little bit.
this needs to be 6.
Don't erase your boards. Put your boards in the back.
14 plus 2.
Good work today. See you, goodie. Señor, ¿cómo estás?
Bien,
¿Cómo se va?
ça va bien. Comment?
I'm doing okay, and you?
Yeah, pretty good.
Okay, so I have not heard back. Ooh, maybe I shouldn't say that. I had not, but now I have. Kat Haxton says. Okay, so it looks like Ms. Haxton thinks that you should select the national accommodations choice.
Yeah.
And then you qualify for that. You'll only have to submit your ELPA 21 score report. She's not sure how to do that, but she's going to figure that out, okay? So Ms. Haxton is going to work with us. Because what I think that will do then is you will have more time for the test, which I think is really important so that you have time to think about it and not let the language aspect overwhelm you, okay? Cool. So we're moving it along, my friend. So keep checking in, okay?
All
Right. Cool. You gonna be at training tonight? No?
I'm not playing.
Not playing what?
I mean, Wednesdays.
Yeah, but you're not gonna go to practice? You don't want to be rusty for high school season?
I do want.
You do want to be rusty for high school season?
I got me on it too.
Okay.
Yeah.
Careful. All right. Boop, that goes away. What is this? What? That's funny. All right. Aye. Seating charts. Reload last page. No. Ah, donkey.